Hello friends, this video on human eye and colorful world part 2 is brought to you by examfear.com. No more fear from exam. So now let us look at the image formation by eye. So as I mentioned before also, where is the image formed? Let us suppose this is our eye. And this is the object which we are seeing. We are looking at this ball. So what kind of image is formed on the retina? A real and inverted image. Now this image which is formed, these signals are then carried by the optic nerves to the brain, and then brain interprets it, or brain transforms it into a erect image. Now focal length of the eye lens is varied by the ciliary muscles that I have already mentioned before. Now what happens to the eye lens when it views a distant object? Let us suppose if I am viewing a very distant object, that means the object is located at infinity, right? But I want the image to be formed at the focus. When object is located at infinity, where is the image formed? The image is formed at focus. Now in case of eye, I want the image to be formed on the retina. That means the distance of the retina from the eye lens should be equal to the focal length of the eye lens, right? So that means you have to change the focal length in such a way that the focal length of the eye lens is on that the principal focus of this lens is on the retina, so that the image is formed here, right? So for distant objects, what happens? The ciliary muscles get relaxed, so that when the ciliary muscles get relaxed, now when the ciliary muscles relax, what happens? The lens becomes thinner, and as a result the focal length of the lens increases, and maximum possible focal length is retina, because that is the beyond that there is no eye. So the maximum possible focal length that is possible is retina. So the ciliary muscles relax as much as possible, so that the focal length increases to its maximum value, and the maximum value is the retina. As a result, image is formed on the retina. Whereas in case of nearby objects, when we are looking at some nearby objects, the ciliary muscles contract. Now when the ciliary muscles contract, when these muscles will contract, there will be a push from both the ends, because it is contracting. As a result, the lens will thicken. Now when the lens is thickening, what is happening? The focal length decreases. It is something like this. If your lens is thin, in that case the curvature is less, this focal length is more. But if your lens is thick, in that case, if you look at the circle which is formed, so the focal length in this case is less. So that means a thick lens will have a lesser focal length as compared to a thin lens, right? So in this case, what will happen? When the ciliary muscles contract, the focal length will decrease, and as a result the image will be formed beyond the focal length, because now the object is little closer. So when the object is little closer, your image should be formed beyond the focal length. That is what we have studied, right, in our previous lessons. Correct? So what did we study? We have studied that when an object is at infinity, the image is formed at focus, and when the object is coming closer, the image is going away. That means the image should form beyond focus. So in this case, when you decrease the focal length by the contraction of ciliary muscles, so the focus will now shift closer. The focus will not be on the retina now. So the focus will be somewhere here or here. So now the image will be formed beyond focus, that is on the retina again. So this is how, by changing the focal length of the lens by expansion or contraction of ciliary muscles, we are able to form images of distant objects as well as close objects on the retina. Now let us talk about something called power of accommodation. What do I mean by power of accommodation? Ability of the eye lens to adjust its focal length to see both distant and close objects. That is called power of accommodation. That means how much the eye lens can adjust its focal length. There has to be some limitation. It cannot, the ciliary muscles, what is the extent up to which the ciliary muscles can expand or contract, right? So we will see that. Now, in this case, as I mentioned below, the ciliary muscles when ciliary muscles will contract. In this case, what happens when the ciliary muscles contract, it forms a thin lens, and thin lens will have a greater focal length. As I mentioned before also, if you see, these are my ciliary muscles, right? So when these ciliary muscles try to come closer with each other, what will happen? It will try to make the lens thinner, right? So when the ciliary muscles contract, the lens becomes thinner, and a thinner lens has greater focal length. So your focal length increases. But what is the maximum value of focal length that is possible? The maximum value of focal length is this much value, which is the retina. It cannot be more than that. So that means there is a limitation to the contraction of ciliary muscles. There is a maximum value of focal length up to which the ciliary muscles can contract. So the ciliary muscles cannot contract beyond that. Similarly, when we talk about nearby objects, what happens? The ciliary muscles expand. So when the ciliary muscles expand, that means these muscles get relaxed, they move away from each other. So the lens is also allowed to become thicker. So a thick lens have decreased focal length, right? But in this case also there is a limitation up to which the ciliary muscles can expand. Since the ciliary muscles have a limitation of contraction and expansion, therefore there is a limitation for the eye that it can see. There is a minimum distance from which I can view things clearly, and again there is some maximum distance up to which I can view things clearly, because there is a limitation to the contraction and expansion of ciliary muscles. So when I talk about power of accommodation, I mean the ability of the eye lens to adjust its focal length so that it can view both distant objects and closer objects clearly. So that means it can accommodate both distant objects and nearby objects. That is why it is called power of accommodation of the eye. Now let us talk about the least distance of distinct vision. So when I talk about least distance of distinct vision, let me ask you something before that. Have you ever observed that if you take your book very close to your eye, are you able to read things? You are not. Again, if you take your book very far away from you, are you able to read things? No, you are not. Why does that happen? As I mentioned in my previous slide, that there is a limitation for the ciliary muscles to contract beyond which they cannot contract. So because of that, the focal length, the change in focal length or the focal length can also be decreased only to a certain minimum value. If you look at the previous slide, you can see that the ciliary muscles can contract. When ciliary muscles contract, the focal length increases. So the focal length can increase up to retina. So it can even view objects which are placed at infinity. But what about the nearby objects? For viewing nearby objects, the ciliary muscles has to expand. But there is a limitation up to which the ciliary muscles can expand. It cannot expand beyond that. So because of that, thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.